triangle, and at the corresponding vertices, angles are also there. Hope you can understand. Angle A, angle B, angle C. Right? And second point, what I have given, if you are taking the length of the two sides, they are the comparable. The sides are comparable. Sum of the two sides is greater than the third side. Similarly, for angle also. And these are all the concepts. Second point related to the second point. Let us see here. These are all the points already you have studied in 8th, 9th, and 10th standard.
Sir.
What is meant by an equilateral triangle,
Triangles.
isosceles, scalene, and even for angles also. I have taken the length of the sides. Even if you want, you can discuss with the angles also. Suppose each angle is 60, we can call it as an equilateral. One angle is 90, rest of the two angles are 45, 45. That is isosceles. And all the three angles are different. We can call it as a scalene. That is what I have discussed in the second and third point. Sir, why you are taking these two lines? We can call it as a sticks, and we can call it as a modulus. This is called as a modulus. When we are taking two lines, which will give an absolute value. Absolute. Here I have given an examples also. Now, in the fourth point, actually I have entered into your trigonometry concept. Everything will be discussed by right-angled triangle. In a right-angled triangle, you can write. In a right-angled triangle. Everything will be discussed with a right-angled triangle. Clear? And for our convenience, we can call it an opposite side or perpendicular to angle A. And it is denoted by theta. This is the symbol theta, alpha, read as beta, read as gamma, read as delta. These are the different notations for representing an angle.
Sir,
So here it is. Just 1 second, please. I'll come to you. Adjacent to A is adjacent side, or we can also call it as a base. And perpendicular to opposite, opposite side or perpendicular to theta. Let us see, theta is here, or angle A is here. Opposite to angle A is perpendicular, and we can call it as an hypotenuse. Hopefully, everyone is known regarding to the Pythagoras theorem. Based upon the Pythagoras theorem, for our convenience, these are the 6 trigonometric ratios are discussed. What is meant by sin A, P by H, cos A, B by H, tan A, P by B, cot B by H. The first 3 are known. The rest of the 3 will be their reciprocals, as I have discussed even yesterday. And today I have shown 2 paragraphs, the 2 slides which I have shown to you for better understanding of these 6 concept parameters. You can able to define sine, cos, tan. And then
sir, I have a doubt. Can we
just
call
1 second, I'll come to you. I will come to you. Just 1 second. Listen. Okay. So this is the previous class that I'm revising. After completion of this, I'll come to you. So these are the 6 trigonometric ratios are defined for understanding of 3 sides, 3 angles. Vertices are also there. At the same vertices, we are taking an angle. So 3 sides and 3 angles. For better understanding of these 6 parameters, what are those? 3 sides, 3 angles. 3 angles. That is angle A, angle B, angle C. So 6 ratios are defined. How they are defined? Sin A will be perpendicular to sin A. A means here, what is an opposite? We can call it as an opposite. Opposite to theta is what? BC. This is defined as BC. It is BC divided by AC. This is defined as AB divided by AC. And tan means it is sine upon cos. Clearly, it is defined as, what is that? Sine upon cos. BC upon AB. And it is the reciprocal. Cot is the reciprocal of tan. It should be AB upon BC. Like that. Secant is also the reciprocal of what? Cos. So it is H by B means AC upon AB.
AB.
Similarly, the last one, cosecant, as I said, so cosecant, if you are observing sine to reciprocal, that is equal to AC upon BC. These are the things yesterday we have discussed. If they are reciprocal, then their product, apply cross multiplication, sine cosecant will become 1. Cos secant will become 1. Tan a cot will become 1. What is meant by tan? Sine upon cos, as we have discussed. Yes, Rohan.
Sir, if you take B as theta, sir, in the right angle triangle.
That is yesterday I have given, where right angle triangle. At right angle, without right angle, you cannot define these ratios. At right angle, you cannot take it as theta, because already it is 90 degrees.
Okay.
Where it is perpendicular, you cannot define at right angle as theta. You cannot consider at B as theta. Very good.
Okay.
Ranveer. Ranveer, any doubt? Any other doubts, guys, regarding to the previous concept as we have discussed yesterday? Any other doubts?
No, sir.
Right, we'll go for the next point, the next slide, which I have started, revising of the previous concept. That is the 6 ratios and their reciprocals. If you are observing, sine reciprocal is cosecant. What it means, cosecant means what we can write, cosecant theta, that is H by P. What is cosecant theta? That is reciprocal, H by P. What is secant theta? That is H divided by B. What is cot theta? That is B divided by P. And same thing that I have discussed even yesterday also. And by using this concept, your Pythagoras theorem, I can prove, I can have few of the identities. What are those? Let's see here. The identities are going to discuss. You know that by Pythagoras theorem, point number 7, by Pythagoras theorem, by Pythagoras theorem. What is Pythagoras theorem says? AC square is equal to
So
AB.
sum of the two sets will be equal to the hypotenuse
square
hypotenuse square.
H square will be equal to B
Good.
square plus.
Yes. Yes, very good. AB square is equal, AC square is equal to AB square plus BC square. So I can prove the identities, trigonometric identities, or we can also call it as formulas. Formulas are important identities. How? In the first case, case number 1, divide above equation by AC square. I can divide your equation 1 by AC square. AC square divided by AC square is equal to AB square divided by AC square plus BC square divided by AC square. Nana, AC square divided by AC square, that is 1. And I can take it as AB divided by AC, but it is whole square, plus BC divided by AC, that is a whole square. Just now I have given to you what is mean by AB upon AC, BC upon AC, AB upon AC, BC upon AC, AB upon AC, AB upon AC, adjacent upon hypotenuse. It is cos theta. Just now I have discussed. So 1 is equal to, it is cos theta whole square. And what is meant by BC? Opposite. It is
Sin
sin
theta.
theta. Very good. Which implies that cos square theta plus sin square theta is equal to 1.
Tan theta.
1, sir.
This is the first identity you have to remember. From this, if you want, you can derive two more. What are those? Let's see here. Let's see.
Cosecant square theta minus cot square theta equals to 1.
Cos square theta is equal to 1 minus sin
Equals
square
to 1
theta.
minus sin square theta.
Right.
Cos square
Again,
theta-
sin
cos
square
theta
theta
equals-
is equal to 1 minus cos square theta. These are the two identities. Okay. Hope you can understand this. Any one will be taking us on right hand side. Cos square theta is equal to 1 minus sin square theta, or sin square theta is equal to 1 minus cos square theta. So how many identities we derived? 3 from the first case. Yes, I can go for the next second case number 2. What is the second case? Case number 2. Divide the above equation by AB square. First one is
Sir?
what? AC square. Next, AB square. Yes, please.
Sir, by Pythagoras theorem, we are deriving all these.
Yes.
That means these are all assuming. We are assuming only, sir.
No, it is showing that but right angle triangle Pythagoras theorem showing that hypotenuse square is equal to sum of the two squares of remaining two sides. We are not assuming anything. We are taking directly from Pythagoras theorem. You know the statement of Pythagoras theorem?
Yes, sir.
Yes. Hypotenuse is equal to, right? We are dividing by AB square from this.
The
AC
hypotenuse square is equal to side square, side 1 square plus side 2 square.
Right, very good. This is AB square plus divided by AB square. We are dividing by AB square plus BC square divided by AB square. BC square divided by AB square. AC divided by AB whole square. AC divided by AB whole square is equal to AB by AB. Next, BC divided by AB whole square. Try to keep in mute, guys, all of you. And if you are observing that AC by AB means, is it secant? Is it
Yes, sir.
secant? Make use of the right angled triangle. You can observe, and it is 1 plus BC divided by AB. That is a tan.
And
Tan. You can
Yes,
keep
sir.
all the
If we
ratios. All
1
the
is equal to
ratios.
minus
Secant square theta
minus tan
is
square
equal to
theta equals to 1.
1 plus tan square theta. Is it clear? This is the second identity I proved. Second identity. And even from this, we can deduce two of the identities same as the previous one. What is the
Sir?
first one? Yes, please.
sir, can we write cos theta is equal to root over 1 minus sin square theta?
Yes, that's we will discuss later. Okay, that's we will
Okay.
discuss later. We are deriving, we are proving the identities now. Everything will be discussed later. So sec square theta minus 1 is equal to tan square theta. Next, sec square theta minus tan square theta is equal to 1. So these are the, again, three identities can be deduced. Three of the identities can be deduced. You have to remember all the three. First one 3 and the next 3 also. Because this takes an important role, guys, while we are solving the problems, discussion of the questions. You have to use these identities. And this is important for us. Sec square minus tan square is equal to 1. Hope you can understand the second one also. And one case is remaining. That is the third case, last point. Case number 3. What is that? Divide by, is it BC square? This is remaining AC square divided by BC square is equal to AB square divided by BC square plus BC square divided by BC square. So AC divided by BC whole square is equal to AB divided by BC whole square. BC divided by BC value is 1. What is meant by AC by BC? Is it cosec? Cosecant square theta is equal to AB divided by BC value
1 plus
cot
cot.
square theta. Yes. Plus 1. This is the next identity. Next identity. Even we can deduce two of the following. The first one, cosecant square theta minus
1 plus cot square theta.
is equal to 1. The next one, cot square theta is equal to cosecant square theta minus 1. Right. These are the total 9 identities I proved, guys. We proved. Let's see. Any doubt regarding to these identities? I mean, wherever, suppose we may have some doubt, sine square theta plus cos square theta or sine square theta minus cos square theta. Whenever we have the doubt, we can make use of Pythagoras theorem and try to divide each part, each side square. You can able to get all the 3 trigonometric identities or formulas. Whenever we have the doubt while we are solving the problems, we can make use of the proofs also. Yes, please. Is it clear?
Yes, sir.
I'll go for the next concept. That is an angle. And before going to that, I'll try to make a note of all the formulas. Total 9 formulas I have given to you. 9 formulas I have given to you. Just we can keep at one place all the 9 formulas. We can keep all the 9 formulas at one place. What are the formulas I have given to you? The total 9 formulas, guys. I can take all the 9 formulas at one place. Just 1 second. I'll try to copy the formulas. These
Sine
are the
square theta
formulas.
plus cos square theta equals to 1.
Now we can have all the 9 at one place. What we proved. Yes. The first 3 related to sine, and then cos, sine square, cos square. These are the 3 are related. And then tan, secant, tan and then secant, secant and then tan. They are related to each other. And then the last one, that is the cot and cosecant, or the rest of the 3. I'll go for the next point, point number 8. Angle. Angle. Even yesterday I have given the definition. It is an amount of rotation. Amount of rotation with one fixed line, and one variable line which is moving. Fixed ray and terminal ray, what we can call that. And even downside is also possible. The angle is also possible in downside. This is the ray of the line, what we can call it as a initial ray. Initial ray. It is the terminal ray. terminal ray. It is also same terminal ray. It is what? The amount of rotation in anti-clockwise direction. Amount of rotation in anti-clockwise direction. In anti-clockwise direction. Clockwise direction. Denoted by theta. If you are observing, we can measure in anti-clockwise direction. It is a theta. Denoted by theta. Read as theta. Sir, what happened when I'm moving, when I'm taking an angle in clockwise direction? That is in opposite direction to theta. We may get what? Minus theta. It is minus theta. So if the rotation made in clockwise, then your angle can be negative, minus theta. Suppose here minus 45 is there, it should be plus 45. Plus 45, minus 45. Downside, clockwise is given to you, then it should be in negative direction, right? So in downward direction, that is in what? Clockwise direction. In clockwise direction, angle can be measured, taken as minus theta. Angle can be taken as minus theta. Clear? Hope you can understand positive and negative. Suppose we have the coordinate system. Is it clear regarding to this angle measurement? The angle can be measured in anti-clockwise direction always. Suppose if you are taking in clockwise direction, then the angle can be taken as minus theta. Any doubt, please, regarding to this concept, angle?
So please explain once again.
Where you are not understand. That is a simple definition. Even yesterday I have discussed this concept.
So in clockwise
Suppose if you want
direction,
to yes,
it is minus theta, sir.
it is minus theta, negative.
Okay, sir.
Right, one thing, where we are using this concept, just I'll tell one example. Suppose if you want to cross one vehicle on the road, we people have to bend, and we will see if any vehicle is there in front of us. The bending movement is nothing but an angle. We can call it as an inclination. So we can bend like this and we can see any vehicle is coming in front of us. If it is coming, then we'll not cross the vehicle. Yes or no? The bending movement is nothing but an inclination, or we can call it as an angle. That is an 8th point. And point number 9, coordinate system. 9th point is coordinate system. So trigonometric ratios and their position in the coordinate system. Let's see, we have the 4 quadrants, and this is x-axis positive, and it is y-axis positive, and you know that we can call it as quadrant number 1, we can call it as quadrant number 2, and this is quadrant number 3, and it is quadrant number 4. As I said, we can measure an angle in anti-clockwise direction. Anti-clockwise.
Sir,
And
we
this
can
is
go
9.
in this all silver teacups, no, sir.
That is I am discussing now. that is 90 degrees. First one is 90. Can we take theta as 90 here? 90 degrees. And this is also one right angle. 90 plus 90, theta value at this place, is it 180 or not? 180 degrees.
Yes,
And in
sir.
downside, it is also 90, Nana. 90 plus 180, is it 270? Right. And here I have
Yes,
started
360.
the measurement as 0, and theta will be how much? The 360 also. I mean, to complete one circle, if you are observing, let us take that one line. We have started, and we can rotate, we can complete the total circle. That what is theta value to complete the total circle? That is 360 degrees. It is 360 degrees. Clear? So to complete one circle, one circular figure, closed figure, we require the total amount will be 360 degrees. What is in first quadrant? 0 to 90. Second quadrant, 90 to 180. Let us see. Your angle will be 0 less than or equal to theta less than 90 degrees. 90 less than or equal to theta less than 180 degrees. 180, which is less than or equal to theta less than 270 degrees. 270 less than or equal to theta less than
Equals to 360.
360 degrees. First coordinate system, quadrants, and then the angle, and each quadrant is 90 degrees. And after that, what is mean by this first quadrant? In first quadrant, all trigonometric ratios are allowed. In second quadrant, only sine theta and cosecant theta is allowed. In the third quadrant, tan theta and its reciprocal cot theta is allowed. In the fourth quadrant, cos theta and secant theta is allowed.
Then what is the value of theta, sir?
That's depends upon the requirement, and the value is suppose if we entered into the first quadrant, theta value may be 20 degrees, 30 degrees, 40 degrees, 70 degrees. If you are in first quadrant, suppose if you are in second quadrant, your theta value lies between 90 degrees to 180 degrees. Sundar, any doubt?
Sir, yes, sir.
Any doubt?
Yes, sir.
Any doubts? Any doubts you are having?
Yes, sir.
You can ask. Yes, you can ask.
How can you find out we are in which quadrant, sir?
That he will give. No problem. He will ask the question like suppose for example theta is equal to 150 degrees in which quadrant? 150. That second quadrant. He will ask. No problem. Okay.
Okay, sir.
That's I want to discuss in the next part. Hope you can understand. First quadrant means you are in 0 to 90.
Yes,
Second
sir.
quadrant means 90 to 180. Third quadrant means 180 to 270. Fourth quadrant means 270 to 360. Hope you can understand. We are starting from 0, which is a positive initial ray. Initial ray. Starting from theta is equal to 0. If we start with a 0 and close with one circle, the angle will be 360 degrees.
Sir,
Yes, Navneet.
sir, can we tell that there is a infinite number of angles in a circle?
Infinite number of angles. Yes, you can take 30, 40, 50, 1 degree, 2 degrees, 0.5 degrees. Yes, but in trigonometry, we can fix few of the values. Only few of the values are going to fix it, because I cannot remember all the values of the trigonometric ratios. I can have only 6 ratios. The values I can remember only few. Some standard tabular values will be given to you. standard tabular values given to you, you have to remember only those values, whatever it may be the asking. Suppose he's asking 135. I can make use of few of the initial values, right? I'll try to discuss each and everything step by step. You don't worry. Hope you can understand this coordinate system.
Sir.
Yes, sir.
Yeah, sine theta. In which quadrant sine theta? Quadrant number 2.
Yes, sir. Quadrant number 2.
Tan
Two, sir.
theta, quadrant number 3.
Yes, sir.
Quadrant number 3, tan
Yes,
theta.
sir.
Cos theta, secant theta, quadrant number 4.
Number 4.
Yeah. In first quadrant, all are allowed.
Yes, sir.
Everyone
All
will
six.
be allowed.
All
All
six
6
are
will be allowed. Yes, very good. So suppose sine theta wants to enter in quadrant number 4, then minus sign will assign. That we will discuss later in the next point. Hope you can understand the coordinate system, guys, all of you. Any doubts regarding to the coordinate system?
No, sir.
No, sir.
No,
sir.
sir.
Can I go for the next point?
Yes,
Yes,
sir.
sir.
Yes, sir.
Sir, this
Right.
one
Yes,
only,
sir.
all silver teacups, something.
Yes, sir. It is there, sir. I'll try to go for the next point. The next point. How to remember these 6 ratios, in which quadrant they enter, in which quadrant they allowed. That is all silver tea cups. All means all 6 trigonometric ratios. This is sine and what? It's reciprocal cosecant. T means tan, starts with the T. And then it's reciprocal cot, starts with the C. That is cos and it's reciprocal secant. So here it is quadrant number 1, quadrant number 2, quadrant number 3, quadrant number 4. All silver tea cups. This is what he has given the word for remember in which quadrant your trigonometric ratios are allowed. Just make a note of this coordinate system. The coordinate system is important for us. Just make a note of this. Make it fast.
Sir,
Yes, please. You can.
how do we remember all the 9 formulas, sir?
Already we proved, no? We proved.
Sir, we can remember the 3 formulas and then we can
Yes.
do
Yes.
the other calculations.
Not necessary. Suppose you're not interested to remember, just you can make use of Pythagoras theorem and keep on doing, keep on
Yes,
dividing
sir.
the first term, second term, third term. We proved, Rohan. Okay.
Okay.
So you should be habituated because this is a chapter which takes an important role in maths as well as physics. You can able to remember because number of questions are going to solve in future. Trigonometry is such. That's I'm discussing one by one, no problem. Let's make a note of all these points. Okay. Yeah, so if you want, I'll try to finish up your class within 1 day, total trigonometry 1 day. Or if you want, I can complete your trigonometry with 1 month or 2 months. Because it is such a topic, takes an important role, guys. Okay, so don't be hurry. Let's moving to the next point. Next point. Measurement of an angle. Just angle definition is given. Coordinate system is also given to you, and which quadrant your trigonometric ratios are allowed. The place of the trigonometric ratios, already we have represented them, and x-axis theta value is 0 and 180, and y-axis theta value is 90 and 270. That one more point that I'm going to add in coordinate system, guys. This is takes an important role. Let's see. I'll try to use. This takes an important role. What is that? Let's see here. It is 90 minus theta. This quadrant is 90 minus theta. Or let us see here. This is 90, something less than 90. And if you want, you can take even 360. We have completed already. 360
360 plus theta.
and if I entered into the second quadrant,
Sir, 180
90
minus theta.
90 plus theta.
and
180
180
minus theta.
minus theta.
Sir,
And we entered, yes, please.
sir, for the first quadrant, sir, can we take 0 plus theta?
0 plus theta means it is theta only.
Okay, sir.
Yeah. So 180 plus theta, and if it is 270, if you are
minus
considering 270 degrees minus theta.
Sure.
Very good. Next,
270
fourth
plus
quadrant.
theta.
70 plus theta,
270
360
plus
minus
theta.
360 minus theta.
Very good. 360 minus theta. These are the important concepts are going to remember, and this is important, guys. Just last point which I have written, this is important for me. While we are solving the problems, this concept takes an important role. There is 90 minus theta, 360 plus theta, 90 plus theta, because if you are observing on a vertical line, 90 and 270 is given to you. On a horizontal line, 360 and 180 is given to you. So based upon the given angles, you can able to understand this coordinate system. Is it clear, guys?
Yes, sir.
Yes, sir.
Yes, sir.
Right, right. That's it for today, guys. We'll try to continue in the next class. That's it for today.
Yes, sir.
If you're having any doubts, you can.
Thank you, sir.
Bye, bye. Good
Thank
night, guys. Good night.
Bye, sir.
No doubts, sir. Good night, sir.
Thank you, sir. Bye, sir. Good night.
Bye.
Thank you, sir.
Thank you, sir.
Good night, sir. Good night, sir.
Thank you, sir. Good night.
Thank you, sir.
Good night.
Good night,
Good night, everyone.
everyone.
Sir, good night.